Today we'll be taking a look at subsets and the power of sets. Alright, I have some text here. We are going to run through this text together and explain each as we go ahead. Alright, so from this place we have that subset simply say for set A and B, set A is a subset of B if every element in set A is also in set B. Alright, if every element in set A is also in set B. Okay, so it doesn't necessarily mean that every element in set B must have to be in set A, because here subset simply means that our B, okay, B is the larger set. Okay, the B is the larger set, while the set A is the smaller set. Okay, smaller set, while set B is the larger set. So we can form the smaller set from the larger set. We'll see some examples later. Then when we talk about subsets, subsets can be proper subsets or just subsets. Okay, subsets can be proper subsets or just subsets. So if they are proper subsets, we use the symbol this to represent proper subsets. But when you see this symbol and a dash under, it means this is just subset, not a proper subset. Not a proper subset. Then what is the difference between a proper subset and just a subset? Every smaller set that can be formed from the larger set is a subset of that set, but not all of them. Okay, there is a particular one that is not a proper subset. Okay, there's a particular subset that's not a proper subset, and that is the set that will be formed when you use every element of A. If you use every element of B, rather, if you use every element of the larger set to form the smaller set, then that particular set is not a proper subset. It is a subset, but not a proper subset. Okay, not a proper subset. For example, let's see a set like P equals, we'll just use a simple C, A, and T. Okay, C, A, and T. So I want to form subset from here. The first subset I can form from here will just be an empty set. Okay, will just be an empty set. Either we write it this way or we write it this way. All right, so this is an empty set. This is a null set, and this is an empty set. Both of them describe an empty set. So we can also form a set that has only one element inside. We have C, then we have A, then we have T. Okay, we have T. Then we can form sets with two elements. Let's say C and A. Okay, then let's say C and T. I think we can also form C. Okay, A and T. A and T. All right. So we have 1, 2, 3, 4, 5, 6, 7. 7 proper subsets. So we can also form CAT, since this can also be formed from here. So, but this is not a proper subset. This is just one of the subsets, but not a proper subset. This is the only one that is not a proper subset. So if we use the entire element or member of a particular set to form a subset, then that subset is not referred to as a proper subset. So to a proper subset, okay, the number of proper subsets that can be formed from a given set is usually the number of sets that can be formed, which is given as this. Is that clear? Which is given as this, then minus 1, because there is a particular one that will not be a proper subset. So we'll see this later. All right, so that's a proper subset and subset. So from this place we have that okay, this is an example. It says set A is 2, 4, 6, while set B is 0, 2, 4, 6, 8. These are even numbers. All right. So you discover that set A can be formed using some members of set B, members of set B, members of set B, members of set B. That means A is a subset of B. Okay, A is a subset of B. A is also a proper subset of B. So A is a proper subset of B. So that is what this means. All right. So so there are some things that are just important. We need to note that the empty set, okay, the empty set is a subset of every set. The empty set is a subset of every set. So it doesn't matter how many members are contained in the set, which is the cardinality of the set, nor the type of members it has. The empty set is always a subset of every set. So the empty set is also a proper subset of every set, except the empty set. So we can have a set as P being an empty set. So the empty set, if set Q is also an empty set, then set Q is just a subset of P. Okay, it's just a subset of P, but not a proper subset of P. All right, so we have the number of subsets, okay? Number of subsets of distinct subset, okay? The number of distinct subset of a set containing n element is given as this. So this is how we get the number of subsets that can be formed from a given set. While the number of proper subsets is given as 2 to the power of n minus 1, which is this number of proper subset and number of subsets. And this is referred to as the power of a set. This is referred to as the power of a set. So the power of a set is given is referred to as the number of subsets that can be formed from a given set. All right. So for this one we looked at the other time, the number of subsets we were able to form from here was we have here 1. Okay. We have this is 1 here. This is 2, 3, 4, 5, 6, 7, and this one, which is 8. So if we go ahead and use 2 to the power of n, this will be 2 to the power of the number of elements there is 1, 2, and 3. That's 2 to the power of 3. And 2 to the power of 3 is 2 times 2 times 2. And that will give us what? 8, which is the number of subsets that can be formed from a given set. Remember, we said that this is also referred to as what? The power of that given set. The power of that given set. Okay, that being said, let's see. We have this one here. It says list the proper subsets. For the example above. Proper subset for the example above. This is this one. So what we'll have is the very first set will be the empty set. Okay, the very first one, a single member. Then the next one will be where you have two members of the set. Exactly. Then this is the empty set. So where you have the whole 3 members present is not a proper subset, but it is a subset. Okay, it is a subset. All right. So that is that about the subsets and the number of proper subsets that can be formed from a given set. So how do we represent this when it comes to, listen, if we have a set like A we have something like this. We have A here, then we have maybe we have B inside of A. We have B inside of A. All right. So if we are to write this in set notation, we simply say that B is a subset of A and a proper subset of A. Okay. B is a proper subset of A because B is contained inside A. B is contained inside A. So to get a subset that is not a proper subset, that will mean we have something like A. Let's say this is A here. Then our B will also be on top of A because they contain the same element. We have B on top of it. You can see why this is not a proper subset, but it is a subset. Okay, B is a subset of A, but not a proper subset. All right, so that is that about the subsets. Okay, subset of sets, and also the power of set. We're able to look at subset, just subset, and a proper subset of a given set. If you have any question, leave a comment in the comment section. Bye for now.